Hello everyone, my name is Samreen Kazi and this is the work in collaboration with Dr. Shakeel Khoja, and my work titled is Context Aware Question Answering in Urdu. So let me switch to another slide. So we all know the importance of question answering systems. They enable us accurate information retrieval, and they give us the precise information. But that's not true for most of the low resource languages. And the country I'm coming from, Pakistan, our national language is Urdu. And during the area or during the times of a pandemic, when most of the knowledge was digitalized, so in that time when users who does not have that proficiency with the Urdu language faced difficulties accessing the knowledge. So let's see, this is a user who uses English query to access the knowledge. As you can see, this is the query that I put into the search engine, that is how long is the river Indus, and it gives me direct answers. It also gave me the evidence for the correct questions, and rest of the knowledge is correct as well. While when we are giving the same question with the same but in Urdu only, as you can see, I didn't get the correct answer over there. Even the question clues which are given are not correct over there. Like, this is the length of the river Indus, although this is not correct. And then most of the answers in there, or the clues which are highlighted, are not correct either. So there is a huge gap when it comes to Urdu language, which is low resource language. So the most of these all these things are because of the lack of annotated data sets and lack of most of the basic linguistic tools like NERs and the POS tags and all these things we lack in Urdu. So but there are these two data sets recently, which are UQuad dataset. Another one is UQA dataset. Most of these data sets are actually in the form of question, passage, and answer dataset, but they do not pose actual linguistic complexities of the Urdu, as they are direct translation from Squad using Google. So since we just have only these two data sets at the moment, so we will be trying to make this QA system with these data sets. So we'll start, as I've told you, there is a limited number of the linguistic tools and the resources in Urdu. So we'll start with the basic or traditional algorithms for Urdu QA. Once we don't have the resources to fine-tune large language models for Urdu. Another one is we wanted to make the solid baseline to see that how they actually perform, and to scale it further once needed to see which morphological challenges of Urdu are not addressed by those traditional models. So our work is three-stage framework. It has key sentence identification. We will be first identifying the sentence which contains the answer. Then we will be trying to extract the answer for the answer, which is the actual span in the sentence. And then we will be looking at the probabilities of both the models to extract the unified probability score to see which span is the highly likely an answer. So this is the framework. We are doing the key sentence identification. For key sentence identification, we are using sliding window score. So we have modified sliding window score to align question and the passages together. And for that, we are using instead of using the token terms, we are using noun terms over there, and then we are using the frequency of that, because the answer is mostly in form of the noun phrase or or in form of the entity or the POS tag. So once we have that, then we have another component of this key sentence identification, again, is the semantic similarity score. For semantic similarity score, we have trained a fast text model on these data sets, and because it can handle out of vocabulary words as once we have scores of both of them, we have used that score to identify the key sentence which might contain our answer. Then another part of our system is our framework is answer span extraction. For answer span extraction, since we are using sliding window approach, so sliding window approach gives us multiple spans to us. From the first component, we got multiple spans with certain scores assigned to that. So once we have those scores, so those then based on the length of the span, based on the entity asked in the question, and based on the entity present in the answer span, uh, we have extracted span based on certain criteria, on these criteria. And then with both these features that we have extracted from the answer span and the key sentence identification, for that we have used this logistic regression model. And with the logistic regression model, then whatsoever span got the highest probability, we are taking that as the answer score. So these are the data sets, as I've told you. This UCODE data set that I've told you, it has two different forms in it. One is the machine translated, which is completely machine translated. Another one is a crowd sources form, which for which they have used Wikipedia to make question answer pairs. So we have used this UCODE crowd sources as a test set for our for our uh, question answering setup. And then this is another one, UQA, that is machine translated as well, and that is also the squad translation of that. So we have used EM and the we have used exact match and the F1 scores to get the scores for our model, and then compared it with the traditional n-gram. In n-gram, we have used bigram and the trigram over there. And then we have used this TF-IDF algorithm as well to get the answers to the questions. So our model performed it better than both of these traditional models. We cannot say that it's performing as better as if we might be comparing it with the LLMs at the moment, due to the resource restrictions that we couldn't, but we are planning to do that. So this is how we have tagged those 4,000 questions in UCODE data sets, which were generated by the crowdsourced workers. So we have tagged them based on what, who, when, where, and why, and how. As you can see that what questions and why and how questions have not performed better as compared to the rest of the questions. That's because of the inherent complexity which is into the morphological structure of the Urdu, because one question can be asked in the multiple ways as well. So we found those challenges, that these are the areas of the improvement that when we'll be moving towards the bigger models, we can work there as well. So we had data set limitations as well. We are planning to data set limitations, because it's only the machine translated version, and the model at the moment, it focused on the semantic and the semantic features. It wasn't able to
look into the multiple meanings the words might have. It wasn't able to look at the complex questions or the problematics of the questions, and it wasn't able to do the anaphora resolutions and all these things because it was traditional. So anyways, but this model's effectiveness in rich other low resource languages can also be explored as well to see how it performs in there. So the key contribution at the moment are that we have improved this question answering performance by integrating the sliding window that we have fine-tuned for our work, and then we have used Treebank data set as well to extract the noun phrases from the sentences as well. And to further improve, we have to look into the bigger and the better models to see how and why questions can be improved. Thank you. Yes, any questions?